The Sustainable Development Goals consisted of 17 global goals that were adopted by the United Nations. In conjunction to the theme, SDG 12, Ensuring Sustainable Consumption and Production Pattern, the title is selected which align with one of the targets to achieve the goal. Globally, the rate of pollution due to the release of chemicals and waste into the environment is much faster than the rate at which nature can purify it. Furthermore, there are about 1/3 of all food, which is equivalent to roughly 1.3 billion tons, are produced as food waste each year. In addition, 29% of global energy is consumed in household, which contributed to the emission of greenhouse gases worldwide. In order to solve the world issues, chemical engineers need to approach systems thinking to generate technical solutions in a way that can impact numerous people, places, or things in the systems. As an illustration, system thinking starts by identifying the problem, then generating a hypothesis to address the issue. Once generated, the hypothesis is tested and evaluated from experimentation. Lastly, the changes are then applied to the systems to mitigate the issue. Besides, chemical engineers need to ensure energy efficiency in the various sectors, which means less energy consumption in performing a particular project. This can in turn reduce energy demands while also reduce the operation costs in the production line. To achieve energy efficiency, renewable energy technologies are one of the many ways to accomplish the goal. For starter, we can get energy from wind power, solar power, and hydropower without relying on non-renewables resources such as coal, petroleum, and natural gas. Due to the increasing human population, the demand of water, energy, and food also increases. Hence, chemical engineers should develop sustainable solutions at the water-energy-food nexus. A chemical engineer should think of the three resources as an entity and study the connections between them, together with their synergies, conflicts, and trade-offs that arise from the management of these resources. As the problems of resources shortage and environmental pollution are indefinitely rising, sustainable waste management, especially wastewater treatment, will be a vital process in achieving sustainability. With the advancement of technology, various ideas have been proposed as one of the applications in wastewater treatment. One of the idea includes microbial fuel cells that can be regarded as a promising method to achieve sustainable wastewater treatment. Hence, we will look into the technical and economic viability of this method at a larger scale in real-life application. Microbial fuel cell is a bioelectrochemical device that can generate electricity by the use of electrons obtained from anaerobic oxidation of substrates, in which the substrates present in this case is the wastewater. Microbial fuel cell consists of two electrodes held in separate chamber, namely the anode and cathode chamber. Anode chamber contains of bacteria, which is anaerobic, while the cathode chamber is aerobic. The bacteria in the anode chamber will break down the organic substances in the wastewater to produce electron. The electron will then flow through the electrode in cathode chamber. A relative low current will be produced, and electricity is generated while the waste is treated at the same time. Implementing microbial fuel cell in wastewater treatment will allow the effluent to meet the standards of water reclamation. Since water is one of the valuable resources in the world, this method is especially valuable nowadays to replenish the consumption of water due to growing human population. Furthermore, practical application of microbial fuel cell has great challenges in cost due to its large capital cost to develop the system in a short-term run. However, in a long-term system, the operation of microbial fuel cell could be energy-saving compared to many other treatment technologies. From the statistic, we can see that microbial fuel cell cost roughly $3 per kilogram COD, which is very high capital cost as compared to other treatment technology. However, the operating cost of microbial fuel cell is close to zero. Besides, one of the advantages of microbial fuel cell is its capability to directly extract electric energy from organic substances in wastewater. Moreover, microbial fuel cells work well at ambient temperature and thus consume less energy for temperature maintenance. From the statistic, it was shown that the energy generation of microbial fuel cell is higher than its energy consumption as compared to other treatment technology. Hence, the energy problem can be solved by using microbial fuel cell. In conclusion, although microbial fuel cell can possibly solve the energy problem, there are, however, still challenges in implementing microbial fuel cells in large-scale real-life applications. Therefore, microbial fuel cell could be integrated with other technologies for a more feasible operation.